Hi everyone, this is Kushal Khimani. Today is the third day of the Arduino and Electronic Components course. Let's start. Day 3. So the first thing we'll be doing is making an LED control circuit in series. Like you can see here. $220 ohm resistors, one 9-volt battery, a jumper wire, and 3 LEDs, a breadboard. So it has the 3 LEDs like this in individual lines. These sides be connected. Here it is. One side, the positive and the negative side of one LED each should be connected, like shown here. And there should be sufficient space between the two terminals. Now, using the jumper wire, connect the positive terminal of the last LED to the line where we can connect the battery. Connect the resistor, 220 ohm resistor, to one of the lines or the place we connect the battery. These lines, all these lines, can also be used for connecting to battery. But it is preferred that you use these 4 lines, so that it is a widespread circuit. This LED may not be working. Many LEDs get fused. This LED is working, this is working, but this is not. So this LED is fused. I'll replace the LED. One LED costs very less. So you can get hundreds of LEDs or 20 LEDs, as much as you need, for less price. So it is okay if it bursts or doesn't work. I connected a yellow LED instead. Here it is. Now let's do it on Tinkercad. Let's switch to Google. I have already opened Tinkercad. So let's start. First, we need 3 different LEDs and a resistor. Let's change the resistance to 220 ohms. Now, a battery, 9-volt battery always. And we need a breadboard. We'll use the small one. Here it is. Drag the LED here. We'll connect the battery from this side. Here now. Let's just connect this here. And this. Here. Here it is. And now this also, let's connect here so it looks even. Now I would want this side. Here it is. Positive will be connected to positive. Negative will be connected to negative. Here it is. I'll just drag this a little farther. This resistor will be connected to the negative. So let's connect it directly there. And this side here. And this should be connected here. As it is connected to the last one can be connected here. Let's start the simulation. You can see that all the bulbs are glowing. Now, even if we increase the resistance, they will still be glowing. Because when there are more LEDs, they require more current. So the 220 ohm minimum limit can be thrown into the trash. So let's see if it can take 100 ohm. Yeah, it can take it. But let's see if it can take 50 ohm. Still. Now, what about 25? Okay. What about 20? Still able to take? 10? Able to take? Then let's change it to 5. 5. Still able to take 2? Yeah, 5 is the minimum it can take if you are using 3. So let's see what a 5 ohm resistor looks like. Golden, black, green, and gray. Let's stop the simulation and switch to the presentation screen. Task 4 is LED control via a button. So this is a button. These are all the batteries used because of this button. And let's switch to the Tinkercad screen again. So this here is Tinkercad. Create a new circuit. Now we will need an LED, resistor, push button, a battery, 9-volt battery always, and a breadboard. Let's use a small one. First of all, we need this here. It's always good to use it diagonally, but you can also use both of these terminals. I suggest use it diagonally because it prevents many things from happening, like the LED bursting, or maybe the current flowing directly, or maybe the current getting stopped. Resist here. I just tilt this. Yes, here it is. Connect here and connect here. Now this should be connected to positive, and this here, negative here. Let's start simulation. You can see it is not on. Click it, it's on. Off, on, off, on. So I will be waiting for some time so that you guys can complete it. This is a new concept, so it will take some time to complete. You all should be done by now. So let's switch to the PPT again. So we are done with our task 4. Now let's start with Arduino Uno. So this is the processor which we will be using during this course. So laptops have processors. Processors come from AMD. They have Ryzen processors, Ryzen 3, 4, 5, 3, 5, 7, and 9. And then Intel has processors i3, i5, i7, i9. So these all are processors. There's a fact now. What is Intel's first processor? Commercial processor. It is the Intel 4004. So Arduino Uno. Uno is an open source hardware platform based on a board with a microcontroller at Mega 328P and a development environment, Arduino IDE. It is a software, you will be coding that, but it can be used instead of Tinkercad. If we make the circuit in Tinkercad, we can code in Tinkercad. It acts as Arduino IDE. But if you are using real electronic components, like I've been using for the past 4 months, I use Arduino IDE. So this is the hardware of Arduino Uno. It looks like this. Some transistors, etc. You really don't need to know this, but it's okay if you know. These are the pin mapping. We'll be discussing all this soon. And features of Arduino Uno. It has a microcontroller. It has an operating voltage of 5 volt, input voltage of 7 to 12 volt, and recommended is 7 to 12. It can go to 6 to 20 volt. It has many digital pins, analog pins. It has DC current. It has 20 KB memory, 2 KB RAM. EEPROM is erasable, some programmable read-only memory, ROM, as you know. It is 1 KB. Clock speed is 16 millihertz. So your laptop, it may have 1.7 gigahertz speed. Okay. So this is megahertz. 1000 megahertz is 1 gigahertz. So I'll be showing you the Arduino now in Tinkercad. I'll share my screen now. So this is Tinkercad. Let's get to know the Tinkercad Arduino options. first all and then search for Arduino Uno R3 is the board we are going to use. Okay, so I'll explain now. This is a program. The program goes through this. This is powered using a battery. It may be also powered using a battery. So I have a robot. It is the Arduino line follower. This is the robot. It has an Arduino Uno underneath it here. The battery power, the place where the battery sits. This is the motor shield, Arduino motor shield. This is the Bluetooth module. This is the IR sensor. This body and this shelter and the battery holder are 3D printed by me. It has motors. It has some wheels, etc. But the main part is it has Bluetooth. So many devices have Bluetooth. So you can control this robot through Bluetooth. It is a line follower, so start it through Bluetooth and it will follow a black line on a white surface. Let's continue. So this is the reset button here. This is a light that is connected to GND and 13 volt. So GND acts as negative. And the 5 volt, this 5 volt pin acts as positive. Okay. So this is negative and this is positive. Positive, if you are not using this, you need data to go through and power. So we will be using GND and digital pin 13. So digital pins give answer in 1 or 0. These are analog pins. Analog pins can give answers in different numerals till 1024. So Arduino programs take a very less space on the Arduino. So it will not slow down your Arduino. This is one of the CPUs. It has 2 CPUs. This is the secondary and this is the primary. So let's go to the code. Blocks are there, but it is good to not use blocks. Okay, most of the time. So here it is. Let's take an LED first of all. It will be the same LED. The same LED will be used. Drag and drop it here. Cathode, GND, anode, here. Okay. So this quality, let's change it to the yellow. When you are using Arduino, you can change it, the color. So this LED has a good quality, so it will not be bursting when you give supply. So we can delete this and use a resistor also. There is something called as photoresistor also, which depends on the amount of light. So if you have a lot of light, it will give a lot of resistance. That means it will give less resistance, so 220 ohm-ish. And then if you have low light, it will give more resistance. So let's attach it to GND. Yeah. This will be attached to an LED. Here it is. One LED attached here. And this line will be attached to 13. Now start simulation. You can see it is on because the code is the code given by the program says it should be on for some time and then wait 1 second and then turn off, then wait one more second before you turn on. So this keeps repeating on and on. So let's switch to the PPT. So now you'll be able to understand what this is. One of the processors that I had told you, this processor is called the Atmega. Let's stop the simulation. You can code it in text also. So this is the text code. Let's just remove this. So pin mode you have set to 13, right? Instead of writing 13, we can put a name also. We will be learning this in the following sessions. This is all for today. See you tomorrow. Thank you and have a nice day. If you have any doubts, you can ask them in the live chat. Please feel free to ask any doubts in the live chat. As no one has any doubts, let's end the live stream.